Hi everyone, welcome back to our channel. It's been a crazy week, so I hope you're safe and sound wherever you are. And for this one, to keep it plain and simple, I'm going to show you 10 useful or unexpected ways to use Chrome DevTools. So we're going to use a little bit of plain vanilla JavaScript for this workshop. If this is something you want to review, check out Leon's incredible comprehensive intro to JS. And if you're here for the first time, go ahead and click the subscription button below. I mean, what do you have to lose? Let's begin. Developer console is a common built-in feature in all major browsers. Depending on your preferred browser, you'll have different ways of navigating it. Still, most of them are going to have basic functionalities of checking your DOM, your domain object model, in other words. So it means your elements that are written in HTML or otherwise, the styles that are applied to those elements by CSS or otherwise, and a JavaScript console, which enables you to see variable values and any potential errors. For this tutorial, we're going to focus on Chrome DevTools, as Chrome has become the standard browser and it shares the same interface with a few other browsers popular here in China, particularly UC browser. So if you're on any website, almost any website, with the exception of some of them that are blocking content or style sheet preview, you can just type Command Option I, or Control Alt I on a Windows, and this way you open the DevTools on Chrome. And here you can see that there is a bunch of HTML, some scripts, some style sheets attached, and you can kind of peek into all of these elements on the page. And the nice trick with that is that you can click this button on the upper left corner of the DevTools to select an element on the page and inspect it. So for example, if I want to see this post by Opening Ceremony, a great brand, I want to check out this piece of text over here. So I can see that it's just sort of a span element. And the nice thing about that is that I can actually change the contents of that element and save it in temporary memory just to see how it would look like if I had a different piece of text over here. So for example, this one looks really dreamy and it makes me want to type something like, I want to walk freely on the Windows XP grass. Why not? And you can see that this change has been applied here. So I can do this thing with content, but can I do that with styles? Of course I can. Here, you can add anything you want to element.style. An element is actually an object that describes this particular element on the page, this span. And each element has a style property within its object. So I can change different CSS properties here. For example, I can adjust the font size a little bit. I want to make it bigger. So I'm going to type font-size. And I'm going to make it 50 pixels. Why not? This is really large. I also want to make it Comic Sans. Yeah. Yes, I do. No. Font family. Comic Sans. MS. I'll try to add a fallback. Because unfortunately, not all computers have Comic Sans MS. So here we go. Another cool feature of the DevTools is that you can see how any page is going to look like on a different screen size. And to do that, you're going to use the device toolbar. To open up the device toolbar, you can either press this little button on the upper left corner, or press the shortcut Command-Shift-M, or most likely Control-Shift-M on a Windows. And I'm going to press it now. And as you can see, there is a window within a window. And the inner window is actually a simulation of a different screen size. So here, I'm on an iPhone X. I'm testing my page on a screen size that is equivalent to an iPhone X screen. And the most important one is obviously screen width, because this is what you're going to use for possibly writing your responsive web design later on in your CSS. But you can also test it across many different devices. Here you have a handy list of the most widely used mobile screens, as well as some larger ones, and you can see how your page is going to look like on a laptop as well. You can go all the way from a very, very small screen size, like an iPhone 5, through more like a Galaxy Note, to a tablet, to a small laptop, large laptop, up to 4K TV screen. And obviously, this looks very different now. And this little dark gray circle over here simulates touch. So you can simulate how the page is going to act on a touch screen. One thing you might have not known about Google Chrome is that it has a range of features that enable you to simulate how people are using their browsers differently on different devices. And to open up a menu with that, you can press Command-Shift-P on a Mac, or Control-Shift-P. And here you can see that a menu opened up. And one thing that I was really, really surprised about when I first tested those tools is that there's actually a built-in ad blocker in Google Chrome. So I specifically went on Yahoo, not because I'm specifically a fan of this news website, but more because I knew that there's always a lot of ads on the page. So I'm going to test the ad blocker now. And to do that, I'm just going to search from the list over here, and I'm going to try to find ad. So here we have a bunch of other features. You can, for example, hard reload a page with all the assets and delete all the login features. But here, the one that I'm interested in is block ads on this site. And I'm going to do it now. I clicked, and that's it. And now I should not be seeing ads when I refresh the page. So here we go. Yeah, there should be an ad over here, but there isn't. One thing that is particularly useful for me personally when I browse the internet that most people aren't really aware of is that you can check all the network requests that a page makes for other websites and assets on the internet. So for example, in case of Instagram, what they would often do is that they make it impossible to download images because they want to keep the traffic on the page. So if I right click on the image and try to save as, it's gonna try to tell me that I want to download a web page, which I'm obviously not. So cancel. And instead, what I'm gonna do is I'm gonna inspect this element and see what's going on in here. So we have an empty div here, which is sort of an overlay. And here, the one right next is the actual image. And here I have all the links to the actual raw image files that I can then right-click on. I can right-click on the link over here and open it in a new tab, and I get the image itself. So I can save it now. And it's so much better than just taking a screenshot. And it's really, really useful for all kinds of assets that you're going to be working with. Okay, so now it's time to talk about the console. And the console is possibly the most important feature of the Chrome DevTools along with the Elements tab. The console makes it possible for you to access the JavaScript engine. It enables you to test different built-in functions or the functions that you wrote in your script.js file. It also enables you to perform all the different things that a programming language usually should do. So from simple mathematical operations through testing more complex math functions. And this is something that we're going to do now just to test it. So to keep it simple for now, we're just going to do an addition, 3 plus 4, and you can see that automatically you get the result. You don't have to press enter. And something more complex, 3 times this number, and you get an exponent value here. We can also use a modulo operator, and for those of you who are unfamiliar with it yet, this is, in other words, a remainder operator, which enables you to make a division of a number and then get a remainder as a result of it. So, for example, when we divide 14 modulo 3, it's gonna be 2. There are also other more complex functions that you can use. For example, all the math functions. And the one that's particularly useful here is math.random, which generates a random decimal from 0 to 1. You also always have to remember to actually invoke that function in order to get a result from it. So here we're getting this decimal. If we invoked it again, we would get a different result as well. I pressed enter and the result is already different. What we can do with that, what I think is really, really useful, is that we can multiply it by some kind of an integer, let's say 100. And then to get an integer out of that, we can use math.ceil, which rounds it up to the nearest integer. You can also use mathfloor to round it down to the nearest integer. Yep, there we go. Okay, let's talk about debugging now. And for this purpose, I'm going to introduce to you all a project that I've been currently working on. It's an image slider for sliders. And what we're going to look at now is how it works on the code side of things. And an HTML is just a really simple container with a show reel inside of it, and then there are 4 different images. Each of them is wrapped in a figure kind of element. And then in our script, we only have 2 functions and 1 global variable called counter, and the counter determines the order number of the image that is being shown in the middle of the screen at any time. So it starts at 0, so it's gonna show the 0th image. And if you slide forward, the counter is going to increase, and then the entire show reel is going to be transformed to the left by counter times the width of the entire show reel. And there's a little bit of math going on here with that. But what I really wanted to show you is how I can kind of see on the console side when your code is working, when your functions are being triggered. So here I have a little piece of code. It's called console.log, and this is an extremely important feature in the JavaScript, which you can use to view the values of the variables at any point in your function execution. So when you're unsure about why something isn't working when you think it's supposed to, you can console log the value that determines what should be working at what point. So for example, now what I'm doing is I'm just console logging a string. It's forward FWD, and it gets printed out in the console every time I click the forward button. So I click and I see forward and forward again and forward. And now it may not seem that useful because everything is working also on the front end. But once you run into a situation where something isn't actually working on the front end as it's supposed to, and it works in the console when the console log values being presented are correct, at least you can know that you have to take a step back and see why your code isn't working. Like, where else could be the potential errors? So actually, when I've been testing the slider, I noticed that there's something a little bit off about the counter variable, clearly, because if I click the forward button over here, it still slides to the next image, even though there is only 4 images and not 5. So this is something that can definitely test with console log. So instead of console logging forward whenever I click slide forward, I'm gonna just console log the counter variable every time I click the slide forward button. So this way I'm gonna know what is the counter variable at any point when I move forward. So console.log counter. And now I'm on the first image, actually the second one, because here we're starting the counter variable with 0. And then I'm on the third image, and I'm on the fourth image, 3 over here. And then I'm actually on the fifth image, and there is no fifth image. So I can tell, for example, that my bounds for the slider shouldn't be set up as they are right now, but they should be limited to a number 1 smaller than the one I have right now. So if the counter is smaller than the length of the entire show reel, which has 4 elements actually, if I subtract 1 from this, I'm only going to be able to move 3 steps forward, from the first to the second to the third to the fourth, and no further. And now it's working correctly because I was able to see how the counter variable is affecting it. And that's why console logging those values is very, very useful. Another really cool feature about the DevTools is the built-in debugger, which you can use as an alternative to console logging values. And the name debugger is a little bit misleading because it's not actually a debugger. It's not a tool that's going to automatically debug the code for you. But what it does, it enables you to see values of different variables in your code as you run any of the functions in your script. So here, instead of console logging the counter to try to identify the issue, I can go to my script in the Elements tab. I can go to the script over here and reveal it in the Sources panel. And here I see just the same script as I did in my IDE a moment ago. And what I can see on the left are the numbers of the lines of code, which I can click on to determine different breakpoints where the execution of the code is going to stop, and I'll be able to see sort of like a freeze frame from what the particular values of different variables were when this code was executed at that moment. So I'm going to set it at line 7 and then line 11 so that I can see the before and after of when the counter variable was incremented. So I can refresh the page now. You can see that those breakpoints stayed in place, and I can click on the forward button, and the page has frozen. It's pausing debugger now. And here I can see the local scope of the function that I was working with. So the slide forward function, all the 3 variables that I declared over here, as well as the global scope. And the global scope is really, really large because it also contains the window object, which describes the properties, the size and the location of the browser window which the particular HTML document is running in. So I'm going to have to scroll really, really long to check the value of that variable over here. Generally, by the way, it's not the best practice to use global variables simply because those variable names can easily spill over into other pieces of code that we're using, especially if your project is really, really complex. But here, for the purposes of this simple exercise, it was relatively appropriate. And I can see the counter variable here. It's at 0. And if I keep executing this function again, it's going to change. You can see it changed to 1 because it got incremented on line 9. So this is something that I can see a little more easily when I'm using the debugger as opposed to console.log, along with many, many other values. And you can see that with more complex projects, it's going to give you a little better overview of what you're actually working with. So part of the reason why you should get into the habit of always checking your DevTools whenever you're encountering issues with your project, particularly in the JavaScript part of it, is that you can always see error messages whenever the browser is encountering an error in executing your JavaScript or in fetching some of the sources or assets for your page. So for example, here I can see that on the front end, I'm missing one of the images. But here I can see that the second image is missing for me. And I wonder why. It says failed to load resource. The server responded with the status of 404 not found. So it clearly couldn't find the file that I was looking for. And usually when you see any error code that starts with F4, so 400, 401, 404, it means that there's some kind of problem on your end. So on the end of your HTML or your CSS or JavaScript. If it's a 500 type error, it means that there's something happening on the server side. For example, an internal server error, which can actually mean anything. But here in this case, we can't find the image. And the first thing you need to look into is whether or not the paths are matching. And here, obviously, there's something missing. I need to really, really carefully look into the folder structure whenever I'm working with any of the external assets. So I'm missing the folder name itself. So I have to fix that. And I can see that the image is back on again. So whenever you're encountering any issues, if something looks off or if the code just suddenly stopped working halfway through and it was working before, you might want to look into the error statements. So another cool feature of Google Chrome DevTools is performance testing. And specifically, there's a performance tab related to that where you can record your page as it loads. And it might not necessarily be useful for you at this stage because most of your projects are either going to be hosted locally or on the IMA server. But later on, as you go further with your web development skills, it's going to be really, really useful for you to optimize your pages so that they load really fast across different devices and different networks. So you might run into issues that aren't necessarily apparent after the page loads, but for example, there is some unstyled content on the page and it shows up there for a really, really long time, which is not a really desirable experience for the user. So to record that and then investigate the issue, you can go to the Performance tab in your DevTools and click the Record button, or just use a shortcut command E, and then you can refresh the page. And then you can stop. It's going to start loading your profile. It's processing. Then you can see a really, really complex graph of what different resources get loaded when, and when the so-called re-renders of the page are happening. You have the network part here, which shows you what different resources have been loaded when, and this is a lot of CSS here, for example, in some requests to the Graph API of Instagram. And you can also see when the different frames during the recording session have been loaded. And you can also just isolate different frames. So here you can see it's this is how the page looks like when it's loading, and you don't necessarily have to just like rush and take a screenshot at the exact perfect moment, because the performance tester can do all of those things for you instead. So you can save your time this way. As a treat, we're going to look into the audit section of the DevTools, where you can generate different reports for performance, accessibility, and user experience on any page. And this is definitely not something that you're required to do necessarily for ComLab, but it is something that really, really has to be taken into account. For example, when you want to make sure that your page is compliant with all the requirements of the Americans with Disabilities Act, which is specifically required for all NYU pages since pretty recently. So right now I'm on the yahoo.com website. So I want to figure out how accessible the website is and how it uses the best practices when it comes to CSS and JS. So I'm just going to click Generate Report. So I can see that the page is not doing extremely well performance-wise. It's only at 41 over 100. But clearly it's very accessible. It passes 96% of tests. But what's really, really useful here is that you can also see on all the different specific requirements that you need to pass to pass those tests, and things that could need some improvement and how much you could improve them, specifically by how many seconds in terms of performance. But if you scroll down to the accessibility tab, you can also see what specific visual features could lead to an improvement in that area. So this really kind of leads you through how to make your page compliant, accessible, and performant across different devices. As always, thanks for watching, and stay tuned for new videos next week. Bye!